So let me introduce our next speaker. Uh, our next speaker is also from USA, and he has been working as DevOps engineer for almost 10 years, and currently he's working as senior DevOps engineer at Ring Central, and he's going to introduce us with Kubernetes. So, Mr. Dibesh, please take it away.
Right. Yeah. Thank you, Saroj, for the invite, and I hope all of you guys are safe. Yeah, it's really great to be presenting here. So just to start, yeah, I'm gonna basically briefly introduce Kubernetes here. So, so what is Kubernetes? So just for the abbreviation, it's abbreviated as K8S because there are like 8 letters in between K and S. It's a K8S. You can, whenever you see K8S, it could be, it may mean like Kubernetes as well, right? So what is Kubernetes? So it's an open source system for automating deployment, scaling, and management of containerized application. So when you say automating deployment, it can be used with a CI/CD, continuous integration, continuous deployment, right? To automatically deploy the containers. And when you say scaling, you can go from one container to thousands of containers in very little time. So Kubernetes helps achieve automation and deployment of containers. So Kubernetes was originally it was designed by Google, but now it's maintained by CNCF and a lot of large companies like Google itself, AWS, or Microsoft. They're part of CNCF. So this is the high-level diagram of a Kubernetes cluster. So Kubernetes is a master. It has a master-slave architecture, right? So it doesn't have to be one master. For high availability, you can have multiple masters. Usually the masters are in odd numbers, like for example, 3, right? You can have 3 masters for high availability purpose. But for a simple cluster, you can have just one master and that should work. So there is a master and there is a slave, which is a minion. Kubernetes calls it a node, Kubernetes node, right? So the node has a container runtime, which could be a Docker, which is basically like a standard now, but it does support other container runtime as well. And the slave can, it has a pod which runs containers within the pod. So you don't have to have 3 nodes only. Like you can scale the Kubernetes cluster to hundreds of nodes. So you can have a lot of nodes in a cluster, not just 3. This is just the diagram to show multiple nodes. And this is the this is kind of like a architecture of what's inside the cluster. So in this diagram as well, there is one master, like this shows multiple nodes, Kubernetes nodes, right? So the master has the API server and these components, right? So API server is where the users of the cluster interact, like developers or operators, right? So if you need to deploy your containers in the cluster, you interact with the cluster through API server. Sorry. So etcd is kind of like a store that has all the configuration, all the cluster and configuration information in it. Scheduler, it runs, so so whenever you want to deploy any container, any pod or any pod into the cluster, the scheduler determines, like it checks or determines what the available resource is in the node, and it kind of like schedules the deployment in the specific in that particular node. For example, so you are trying to deploy you are trying to deploy a container, then the scheduler decide if, for example, this node doesn't have enough resources, meaning it is already running multiple containers or pods in on that node, then it would choose this node. So controller manager, there are a lot of controllers like a replica set controller, which kind of like makes sure you have the right number of pods running on a specific node. On the node side, there is a kubelet, which is which manages or takes all the commands from the master and runs the pods or containers in the pod in the node. And kubeproxy is the component where the external users interact with. So the user here are the end users. For example, you are running some kind of like an application, then the users don't interact directly with the kubelet, but with the kubeproxy. C advisor here is basically it gathers metrics about the Kubernetes node and passes it to kubelet, which in turn passes it to the master. And there is a plugin network here. So the plugin network here allows to manage the network within the cluster. For example, so when you create a load balancer in Kubernetes, so there is a separate implementation with separate cloud providers like AWS or Azure or Google Cloud. So when you create a load balancer in Kubernetes, so the specific network plugin in, for example, in AWS, it can create a ELB in AWS. Or in bare metal, like if you install Kubernetes on your own hardware, then you can install something like Flannel, which is a plugin network as well. It can create a load balancer on your bare hardware, like Kubernetes installation. So Kubernetes calls the masters. It makes the control plane, and then the nodes, it makes up the data plane. So there's the distinction between a control plane and a data plane. Oh, so some questions there. Why odd number of masters? It's because in a cluster, you have to have what do you call it? So you have to decide. So if, for example, in a 3-node cluster, if one node goes down, then, so for example, then you have to, even within the cluster, you have to decide like if one node goes down, then you have to decide like which would be the primary master. So that's basically like why it has to be odd number. There would be a voting, like so if you have odd, then there are 2 votes that decides, okay, node 1 is the master, then node 1 is the primary master. If you have even numbers, then the vote would be equal, so there's a conflict. If you have odd numbers, then you have the correct, you have either, you have one vote which is higher than the other one, and you can decide which is the primary master. That's because of that. So some basic concepts on Kubernetes objects. So when you need to deploy any application in Kubernetes, you have to create objects. So these are some basic objects. So deployment, it's basically it's a high-level construct that defines an application. Within the deployment, you define, okay, how many pods you need in a deployment, right? Or what is the image for your deployment? So image in an image in a container is so an image in a container, an image of a container, it has all the application code plus all the libraries. So image is kind of like a package, right? So deployment also defines which image you want to deploy. Similarly, like the pod is basically an instance of a container that is running in the deployment, right? And a deployment can have any number of pods. So we're gonna have a sample deployment that we're gonna run with all these objects. So the service is an object which exposes an application running on a set of pod to the outside world. So for example, if you're running an Nginx service inside a Kubernetes cluster, you want that Nginx to be accessible to the end users. Service helps us achieve that. So namespace, it basically allows you to separate the cluster into smaller logical cluster. What that means is, for example, you have a 3-node cluster with 3-node, maybe 4-node cluster, 1 master and 3 nodes. So you have limited number of resources there, and for example, in your company, you have multiple teams. So maybe there's a dev team, test team, there's a deployment team or other teams. What you can do is you can logically divide the cluster into multiple namespaces. So whatever you deploy in one namespace cannot be seen by other namespace. You can separate the cluster logically. And you can also specify what resource you want to provide one namespace versus the other. So you can basically logically divide the cluster. And there's a replica set as well, which maintains a stable set of replica pods running at any given time. What it does, it makes sure, if you say I need 2 pods running in the cluster for my application, it makes sure there are 2 pods running. Okay. So basically, to get started with the Kubernetes, what you have to do is basically you can create a cluster. You can just have one node. You can have the master and node on the same machine, right? But in the production, it's definitely better to separate them. And if you can install a high availability cluster with multiple master. So kubectl is the command line tool that interfaces with the cluster. So you can do it using Kubernetes provides APIs. You can interact with the API, or there is a kubectl command line tool which also connects to Kubernetes through API server. And after that, after you have the Kubernetes set up, you can create a deployment template. This is the deployment object here. I have a sample here. And then you can deploy using the command line kubectl, like create or apply, and then the file. And then you can check the deployment. We're going to do a simple demo here with this. So as shown, so I have a simple deployment here with deploys Nginx. So just to go here, so this is a type. So the API version is the API version provided by the API server, right? So this is V1. And then the kind deployment, what it means is this is a deployment object. And then the metadata here, it names the deployment. So this deployment name here is Nginx deployment. And then the spec is the specification for our deployment. So what is going to be in our deployment, right? So the replica here is the replica set object that we defined earlier. So 2 tells it we need 2 pods, meaning 2 instances of Nginx container, so Nginx running. So not if you can say I want 10 and it can be 10, right? So the template here defines what container. So like what would be the template for the pod? So the pod contains container, right? So the name of the container is Nginx, And then the image it's going to use is Nginx 1.14.1. So the image here is going to be pulled from Docker container. Let me show you. So if you have your own Docker registry, then you can pull it from your registry as well. But now it is pulling from Docker Hub registry. So you can see here, it would pull whatever version of, so right now I'm pulling 1.14.1, but there is 1.18.0. You can change it to 1.18.0 and it's gonna pull 1.18.0 image, right? This is updated in Nginx official Docker Hub registry. And the port here specifies what port is it gonna expose. So it's going to expose port 80 in the Kubernetes cluster. So if I deploy my if I deploy this deployment here, so I basically deployed it using this kubectl apply. You can use create as well, right? So you can check if it deployed correctly or not by using deployments. So you see here it deployed this Nginx deployment. This is the name, right? You can refer it by name. You can see you can check the deployment by get command, right? And you can see like it created, you can check the number of pods it created. So here you can see there are 2 pods. So 2 pods meaning you have basically 2 containers, 1 container inside of it and the other container inside of this, right? You can access them through service. So you can create a service using let me go through the slide first a little bit. And it has some basic commands here. I'll first maybe go through that. So this is how like I created a deployment using this, right? After that, you can, so kubectl provides a bunch of like, it has a lot of options to do a lot of things, right? So this is basically few commands that you can run. So like I did, you can get the number of pods using kubectl get pods. You can check or get more details about the deployment using either deployment or pods or any object for that matter using describe command. Kubectl describe pod deployment service, replica set, anything, right? And if you want to check the logs on the pod, you can check it using kubectl logs -f. And if you want to get inside the pod, you can use kubectl exec it. And if you want to expose or create a service, then you can use kubectl expose deployment, and you can use load balancer or you can use node port. There are different types of services you can create, right? And get the services that. And if you want to delete the deployment finally, you can use kubectl deployment. So I'm going to run few of these commands right now. So we can check the deployment using. We already listed the deployment using get, but describe, what it does is it describes the deployment. Sorry, I have. So it basically describes what this deployment has. So here you can see that image is 1.14.1, and it was so that the event was it scaled up the replica set to 2. Now, if we want to expose it, we have to create a service, right? So that would be So the name of the deployment here is that. So we can do this. So get service. So it created a service here with the same name as the deployment. And what is, since I put type load balancer, so the cluster I'm using here is not it's a Minikube. So it's a Minikube. You can use Minikube to start up, right? I'm not installing Kubernetes here from scratch. I'm using Minikube, which provides a Kubernetes environment for the development or test purposes, right? So here, I use load balancer in the past slide. I mentioned to use load balancer, you have to install some kind of a network plugin. So Minikube doesn't provide a network plugin by default, and it doesn't create a load balancer. So even though I said type equals to load balancer, it did not create a load balancer. But if you were to do this in AWS, for example, it would create an ELB, Elastic Load Balancer in AWS. So for now, what I can do is I can access this Nginx installation using, so I have to do Minikube service to get the URL for it. I have to do, what it does is it's gonna create a proxy, and then I can access Nginx through this URL. So if I so the Nginx installation is there. So if you want to check the logs, so I accessed it. Now if I can go here, first get the pods. So any one of those two pods could have received the request that I sent. Like this is, I accessed the Nginx, right? Any one of those pods could have received the request. So I can check. So maybe this is not the one. Yeah, so this instance of this pod received the request that I sent. So I can maybe refresh it again. Maybe it may go there. Yeah, it went there again. So this is how you can check the logs. Plus, if you, for example, if you want to troubleshoot something and you want to get into the pods, what you can do is kubectl exec it, and then name of the pod, and then the command that you want to run. Yeah, I am inside the pod here now. And you can see, maybe there's this image has very few tools in it. So it doesn't have even, yes, so, but I can do ls there. And if you want to exit out of it, here. So that's that. So since I don't need the service now, I'll cancel it. And to delete the deployment, so this would delete the deployment. As you can see, there is no pod, but we still have the service that we created. We can delete it as well. Now, if you see, it doesn't have the service. So the namespace that I mentioned, so we are running on default namespace. So you can check what namespaces are there. There are separate namespaces for different purposes, right? There's a system namespace, there's a dashboard namespace, and by default, if you do not specify anything, you're going to run into default. So we basically created our deployment in default namespace. If you want, you can create your own namespace with whatever resource you want to provide, and you can create it, deploy your deployment on your specific namespace. If you want to run command to show you everything in all the namespace, what you can do is namespaces -a, then it's going to show everything. If you want to see on a specific namespace, for example, you can do check service on kubectl namespace. Basically, so kubectl, it has a lot of options to work with Kubernetes cluster. Let me go back to the slide. So we did some of these commands. So there is a concept of health check in Kubernetes as well. So what it basically does is it checks the health of the pods, and based on that, you can decide what to do. For example, so you have an application that connects to the database, does some queries first before that application is presented to the end user. So in that case, what you can do is you can put a readiness probe. Readiness probe is when the container in the pod comes up, the Kubernetes cluster doesn't mark it as ready, meaning it's not going to be accessible to the end user unless the check is successful. So the liveness probe is when, so once the pod is back up and ready, the liveness probe kicks in. So the liveness probe is what it periodically probes the pod and makes sure that the result is okay, to mark it as healthy. If it's not healthy, it's not going to be available to the end users. So there is a simple deployment I have created for that as well. We can maybe it's better to do the demo. So it's basically the similar deployment as the previous one, but with health check. So here you can see additional section here. So the liveness probe, and the readiness probe. So first, when the pod comes up, it checks the pod by making a HTTP GET on /path, right? If on port 80, if it returns HTTP 200, then it's healthy. If not, then if it's not healthy, then that pod is not going to be available to the end users, or it's not going to be available in the service. Same thing for the liveness probe. So we can basically first, maybe we can modify it a little bit to make sure it's not healthy. Let me modify it, and then put a path that's not available. /test on Nginx by default is not available. So let's deploy this. So it is created. So you see here, it has been deployed. We just put one node, for replica set, we just put one. So it just created one pod. So you can put two or however many you like, right? So get pods, if you do that, you can see here, it's not ready. So 0 out of 1 pod is ready. It means like the pod that we created is not ready. What it's doing, it's doing a health check on the pod. So you can do that. You can check using describe deployment, right? We have Nginx HC deployment. So if we check here, so we added a liveness and readiness probe. So there is a period that we have set in the deployment, for example. So what this means is it lets, so after the pod is brought up, it waits for 15 seconds. After that, it checks every 3 seconds to make this HTTP GET call on Nginx pod. So let's check it again. Right now, it doesn't show it as failed, but if you see here, it's still not ready, right? And then if we create, for example, the service for it, like we did earlier, created, sorry. It created the service. No. It's probably, so it created the service, right? It created the service, but let's describe it. So it doesn't have the endpoint yet, meaning like this is because it doesn't, because the pod is not ready yet. So if I try to, so let me delete this deployment. And then make the readiness probe with the correct path. So it's there. Now it's bringing back up just 9 seconds ago. So it's going to be ready in a little bit. Yeah, it's now, you can see here, it's ready now because it passed the readiness probe. So now if we check the service again, you can see it did not have the endpoint earlier. Now it had the endpoint. This is the IP of the pod. So now if I create, if I get the URL from Unique for the load balancer, now I can connect to the Nginx now. There is no Nginx. This is HC. The name of the deployment is SC now. So now I can access this. So the probes are very good to make sure you complete some things first, or make sure the pod is healthy before you expose it to the external end users. Now it's available. So, so the two examples that I showed was just for single application, right? Nginx, there was just Nginx, there was nothing additional there. So, but in the real world, you would deploy application in the Kubernetes cluster where there are multiple applications or multi-service deployment, right? So for when you say multi-service deployment, you could have a front end and a back end that connects to front end that connects to the back end, or there could be middle tier and then multi-layered application in that case. Or you could have multiple, if you're running a microservice architecture, you could have multiple services which needs to connect with each other. In that case, the Kubernetes allows to connect one pod to the other using the DNS name. So Kubernetes itself has a DNS which can resolve each pod or service. So each pod has its IP, and each service can be so each service can be accessed from every pod, right, on the same namespace. So the DNS name for each service would be the service name the namespace, as we saw earlier, we were running a default namespace. So it would be the service name dot namespace, for example, default.svc.cluster.local. So there's an example which would make it a little clear, maybe. So I have 2 deployments here. So there is a WordPress deployment which uses which connects to MySQL. So we can briefly check it. So there is a service. So you can create service using that kubectl expose, or service is an object as well. So you can have a YAML file like this for service, right? You can create a service using this syntax in YAML. So we're creating a service for WordPress, right, called WordPress, which exposes it on port 80, right? And then there is a deployment for WordPress. It's using this image. And then here you can see, when you create the pod or the container, you can set the environment variable for the inside the pod. So the environment variable is the WordPress DB host is WordPress MySQL. So this is the name of the service for MySQL. So the WordPress pod can resolve MySQL using WordPress MySQL, because we're going to create a service for MySQL using name WordPress-MySQL, right? And then you can pass password here as well. WordPress, this is in clear right now, but there is an object called secret, which you can create and use that. But for now, we are just using unsecure password here. This is the actual password here for the database. And so let's create this first. So it created a deployment called WordPress, and we have 1 pod. And same thing, service. You can do services or SVC for Sharp. So you can see, like, it created a WordPress service. It was a type load balancer. Now let's create a deployment for MySQL as well. So it created the same thing. If you see now, service, there is 1 for MySQL and 1 for WordPress. And there's a deployment for that as well, right? So it created 1 pod for WordPress and 1 pod for MySQL. So for WordPress, so let's go back here again for WordPress. So the WordPress is connecting. So we are creating 2 separate deployments, but the connection here is through this the service name, WordPress MySQL, meaning WordPress pod, or the container inside the WordPress pod, connects to the MySQL in WordPress MySQL pod using the service name. So I can connect to this, for example, I can connect to this pod using exec id pod. So I can go there, right? I am inside the pod. So if I ping the service, it resolves the IP of the service, this service, or resolves the IP of the pod of the MySQL pod, right? So you can check here. So here, so this is the file in WordPress. So there is no, yes. So you see here. So the DB host here is defined by the service name. This is how it can connect. So even though you deploy multiple deployments, independent deployments, you can connect one deployment with the other using the DNS or the service name that is provided by the Kubernetes. So so let me try to open it. So WordPress is available. So if there was no connection to MySQL, this would not be available. So this is how you can create a complete application with multiple services and connect each service together. So those are a few demos there, and Kubernetes. So as I showed you in demo, I did not run Kubernetes in AWS, GCP, or Azure. It is a Minikube. You can have your you can install Kubernetes in your bare metal machines as well, right? Or for like if you can go if in the cloud you can use AWS. There's EKS, GKE, or AKS, right? So when you use AWS, this Kubernetes in cloud, what it does is for the control plane, I mean the masters, they manage the masters, and you are basically working with the nodes as well. So it makes your life easy. You don't have to maintain the cluster that much. So if you want to get started on Kubernetes, I put some links here. So this is the homepage for Kubernetes, kubernetes.io, and there is this very good link where you don't even have to install anything, and you can get started with the Kubernetes. Let me show you a little bit. So it also uses Minikube. So you can go here. You can create your own cluster. It actually provides you a Minikube cluster in cloud, and you can work on it. So start the interactive tutorial. It's going to provide you. There is a Minikube. This is in cloud. This is not on my laptop or box. So you can basically get started here. So it's there, and then if you Minikube start, it's gonna create a Kubernetes cluster for you in cloud, and you can run through these examples here. So it's very, you don't even have to have a Minikube in your laptop. But if you want to learn, if you want to go a little deeper, I believe it's a good idea to have a Minikube on your laptop and test it out. So it's going to take a little bit to set up the Kubernetes cluster there. But whatever examples I did, you can do the same thing in the cloud here with this. So that link is in the slide as well. Yeah, that's what I have for today.